The following Stealing the Mind Bible Conference presentation is by Mike Riddle and is entitled Evolution and Mathematical Probability. For a free catalog of over 200 awesome Stealing the Mind Bible studies on DVD, CD, or audio tape, call Compass at 1-800-977-2177 or on the web at compass.org.
He's very fortunate he did that right. I was in Tennessee last week, and a pastor introduced me as an ex-Marine. He immediately did 20 push-ups in front of his congregation. Yes. There are no ex-Marines. Now, earlier today, you heard a number such as 1 trillion. That's going to be small potatoes this afternoon. We're going to be doing evolution, mathematics, probability. Is evolution even possible? We want to look at that case right there. Could it ever even happen? We want to test that. On one side, we have God created all things. Genesis chapter 1 says that. The Gospel of John says that. Colossians 1:16 says that. Revelation 4 says that. But opposing that is evolution. Everything happened by random chance accidents, natural selection, billions of years. Those are the two, yes. That was in my former days. That was back when I was a happy heathen. So what we're going to look at, is it design or is it just chance accident? That's what we're going to look at here. I'd like to start with a quote. George Wald, biochemist and Nobel Prize in Physiology and evolutionist, wrote this in Unscientific American magazine. Time is, in fact, the hero of the plot. What we regard as impossible on the basis of human experience is meaningless here. Given so much time, the impossible becomes possible, the possible probable, and the probable virtually certain. One has only to wait. Time itself performs the miracles. That is evolution right there. Given enough time, anything can happen. So what I'm going to do here is test your credulity factor here this afternoon. Credulity, what does it mean? Your willingness to believe something on little evidence. In other words, how gullible are you? So we're going to take a look at our credulity button here. I've got 4 cards up here with colors on them. Red, green, blue, and yellow. What I'd like to do is turn them over. Got a little magic here, PowerPoint magic. Now I'm going to shuffle them around. Okay, we're going to do a little test here. Card number 1, what color is it? You think, what color do you think it is? Go ahead and say any one of those 4 colors. Yellow. Exactly right. How did he know that? Wow. That was just dumb luck though, wasn't it? That was dumb luck. Let's shuffle them around again. We'll see if we can get this by chance. Okay? What color do you think is under card number 1? Air Force Blue. Air Force Blue. Can't be Air Force Blue, because when we camp out, we have to have our TVs with us. But how did he get that? Was that just dumb luck, or did he know? Or am I doing something sleight of hand up here? Well, let's do it again. We'll do this one more time. Okay? Okay. What color do you think is on? We'll go to the end there. Color under number 1. Card number 1. What color's under that? You know the number most associated with the meaning of number 20 is? You know what number 20 means? Push-ups. We'll talk about that in the second talk. So you said Marine Corps green. Well, wait a minute. How can this be? All 3 people seem to guess it. Was this just dumb luck? Or am I doing some sleight of hand up here? Let's test your credulity factor. Let's roll some dice. If I were to roll 7 2 times in a row, would you let that go by? You might not. How about if I were to roll 7 4 times in a row? Now you're going to get suspicious, aren't you? We're testing how much are you going to allow this by chance, or am I doing something sleight of hand? How about if I rolled 7, 10 times in a row? You would really suspect something suspicious on my part. In other words, your credulity factor is pretty low there, isn't it? You start to get suspicious at 4 sevens in a row. You weren't going to allow this to happen by chance. Just 4 times in a row, you weren't going to allow that to happen by chance. You think I'm cheating. And it might be. So let's look at where we find out probability. Where's probability used? Well, we find it all over the place. Medical field. Whoa, that's pretty scary. Insurance, gambling casinos, advertising, computer technology. It's a risk every time you turn that thing on, isn't it? Genetics, space science. You know another place it's used? Called evolution. Because what is evolution based on? Random chance events. So we're going to look at that. We look at our children. We send most Christian students still go to public schools. And what are they taught there? Evolution is a fact. They're taught that. Evolution is both a fact and a theory. Evolutionists change over time. I was in a public high school last week, and I do get in those. Never had a teacher fired yet, because all you have to do is teach science, and that's enough. Evolution's dead in the water. But I told them, I want you to show me the definition of evolution in your textbook, because not one definition in a textbook I have seen in this country is a correct definition of evolution. They've watered it down so much that it can mean anything you want. So what we're going to do is the origin of life by naturalistic hypothesis even possible? Well, we can look at 2 things. How successful have scientists been in creating life, or even the components of life? Have they done that? Then we're going to look at mathematics. And I'm going to make this statement because this is how Marines talk. You will understand it. Okay, let's look at how close scientists have come. That's the first part. Then we'll look at the probability. Freeman Dyson, physicist and mathematician, and one of the leaders in the evolution movement, wrote a book called The Origins of Life. Here's what he said. Concerning the origin of life itself, the watershed between chemistry and biology, the transition between lifeless chemical activity and organized biological metabolism, there is no direct evidence at all. The crucial transition from disorder to order left behind no observable traces. That's interesting. Let's look at Franklin Mendel, professor of biochemistry, Colorado State University, also an evolutionist, writes this in his book. The origin of life is also a stubborn problem with no solution in sight. Let's look at one more of those. Hubert Yockey, one of the leading evolutionists, PhD in physics, writes this in his book, The Origin of Life. A great deal of effort has been expended in finding theories for the origin of life without success. Isn't this good news? It's going to get better. It's just going to get better. Now that we found scientists can't even come close, let's look at probability. This is, incidentally, a correct probability problem there for getting 7, in case you ever wanted to know. Those are your chances. But let's look at probability. Now, you saw this number trillion earlier. This is going to be the smallest number we work with really here. We're not going for these small things like a trillion very much. But that's what a trillion looks like. Here's some of the other numbers that you normally see. Tens, hundreds, thousands, millions, billions, trillions, quadrillions, quintillions. We're going to go much higher than that. This is small stuff when we talk about probability. Let's take $1 trillion. We'll start there, small stuff. If you were to take 1 trillion $1 bills and stack them up, that would be 67,800 miles high. That's 8.5 diameters of the earth. That's $1 trillion. And think how much we owe. Now let's take a look at that, the trillion. We see how big a trillion is. Let's look at the amazing cell. Darwin didn't know much about the cell at all. He thought it was a blob. We've learned a lot more about the cell. There's no such thing as a simple cell. It is an extremely complex piece there. More complex than anything mankind has ever made. The cell, just some of the things it does. It has energy generators, invasion guards, transport systems, food factories, protective barriers, waste disposal systems, communication links inside and outside the cell city, and molecular machines that manufacture their own replacement parts. That's a pretty complex machine. Did that really happen by random chance, given enough time? Well, here's just some of the parts of that cell. DNA, RNA, proteins, ribosomes, organelles, cytoplasm, flagellum. I know some of you just salivate when you hear the words like that. But I want to talk about one piece here, proteins. Let's just talk about proteins. Cells have thousands of these. We just want to talk about proteins. I want to show you 7 requirements that affect the formation of a single protein. 7 requirements to get a single protein. Number 1, Amino acids. Now, there's lots of different amino acids. There are hundreds of different amino acids out there, but only 20 are used in life. Now, Mike, what are amino acids? Well, let's do a biology review here. Atoms. Everybody understands atoms. Atoms bond together to make molecules, like water, H2O. Then molecules can bond together to make things called amino acids, and amino acids can bond together to make proteins. That's all we need to know. See how easy biology is? It's pretty easy now, isn't it? But now think of this. There's hundreds of different types of amino acids, but only 20 are used in life. In other words, you get one of those wrong amino acids, you're dead in some cases. These things are dangerous to get the wrong ones. So we have to choose just from those 20 out of all the pool that's out there. Then amino acids come in two shapes, just like we have a left hand and a right hand. Well, left and right hand are about the same, aren't they? 4 fingers and a thumb, but they're really not quite the same. When I put one hand behind the other, notice the thumb and the fingers are on the opposite side. So they're not quite the same. See, your left and right hand are mirror images of each other. Well, these amino acids come in two shapes. Guess what we call them? Left-handed and right-handed amino acids. There's other names, but that's the common name we use, left and right-handed amino acids. Well, what's the difference between the two? Well, just like our hands, they're made up of the same components, the same atoms. And also like our hands, they are mirror images of each other. Why is that so important? Well, remember we have to get just those 20 amino acids out of all the different ones? They all have to be left-handed. Every protein in all life forms is made up of 100% left-handed amino acids. There are no right-handed amino acids used in any proteins anywhere in life. And the natural tendency, when we let it go by itself, the natural tendency is always to bond left and right-handedness, which is away from life. It's like a poison to life. All it takes is one right-handed amino acid can cause serious defects in the human body because it causes that protein to fold the wrong way. So every amino acid and every protein in all life has to be left-handed, so we got to choose that now. Number 3, amino acids must be in the right order. So you got to get the right 20, got to get only left-handed ones, and then you got to get them in the right order. You just can't randomly throw them in there. 4, we talk about this thing called the primordial soup. Campbell's needs to get that. This primordial soup where life is supposed to have begun. Well, think about this. That primordial soup, if it ever existed, we've never found any trace of it, but if it ever existed, it's got all these other chemicals in there and all these right and wrong amino acids in there. It's got all 300 different types in there. And when the wrong ones combine with the right ones, guess what? The right ones are no longer usable, are they? The good ones used for life can't be used. In other words, maybe a right-handed amino acid combines with a left-handed one. That left-handed one's now taken out of action. So it's diluting the whole soup. In other words, the ones that we can use for life become less and less and less available. Number 5, we need an energy source. These students don't bond by natural process. It takes energy to do this. And think about this. Just raw energy from the sun doesn't work. Our students are being taught totally wrong. The sun's energy will not do this. See, what you have to have is some mechanism that can capture that raw energy, then convert that raw energy into usable energy. Where'd that come from? That's a very complex machine right there. So you have to have that first. Then we have the problem of oxygen and water. Ooh. Did you know life cannot start in an oxygen atmosphere? This is pretty detrimental because we need oxygen to survive, but at the molecular level, oxygen destroys molecular bonds. It's like a corrosive there, just destroys them. So if there was oxygen in the atmosphere, life could never start. But if there was no oxygen, that means we'd have no ozone because it's made out of oxygen. You know what happens when we take our ozone away? We all become instant crispy critters. The ultraviolet rays of that sun will just come down and fry anything. But then we have the problem of water. Water, we have to have it. But at the molecular level, water is destructive. There's a process called hydrolysis. Hydro meaning water, hydrolysis means water splitting. At the molecular level, what water does, it destroys the bonds, pulls them apart. Water's necessary for life, but it is one of the worst places in the universe for life to begin. I have a serious question now. Are you made up of molecules? Yes, you are. And what does water do to molecules? Destroys them. So what's going to happen the next time you take a shower? How many are going down the drain? Well, thank goodness our Creator thought of everything. He put a little membrane or cell wall around all our cells that protects us. Start taking your cell walls off, you're going down that drain. So think about this. If there's oxygen, life can't start. No oxygen, life can't start. If there's water, life can't start. It's getting better and better, isn't it? Then number 7, we can't invoke natural selection because it hadn't been invented yet. You see, you can't use natural selection until we have life. We're still trying to get life. So don't let anybody be sly in there and try to say, oh, natural selection. No, you can't have that until you have the first cell. So those are 7 requirements to even get a protein. Notice we haven't talked about the RNA, DNA, ATP, and all those other things yet. Now, let's get to probability. Let's do some coin flipping. At the junior high level, it turns into be a neuromuscular exercise. Some of you know that. Okay. How many heads in a row are we willing to accept as a chance occurrence? So what are the chances of getting all heads every time we flip a penny? Now, how many times must I flip that penny probability-wise to get one head? And everybody said twice, right. Flip that coin twice, probability says one of those will be a head. How many times must you flip that coin probability-wise to get 2 heads in a row? Not just 2 heads, but 2 heads in a row. 4, exactly right. Flip that coin 4 times. Somewhere in there you get 2 heads in a row. Do that often enough, that will be your average. Now, how many times must we flip that coin probability-wise to get 3 heads in a row? 8, exactly. Everybody see our probability sequence. 2 to the first power, 2 to the second power, 2 to the third power. Flip that coin 8 times. Somewhere in there you'll get 3 heads in a row. Now, how about 8 heads in a row? Skip ahead a little bit. And everybody does their computers. And how many here do hexadecimal programming and things like that? Okay, thank you. You know how we describe ourselves? We're different. Well, 2 to the 8th power is 256. Now, you could go home and do this tonight. Flip that coin 256 times. Somewhere in there, you're going to get 8 heads in a row. But here's your real homework assignment. Once you go home tonight, flip that coin and get 100 heads in a row. How many times will you have to flip that coin probability-wise to get 100 heads in a row? Turns out to be 2 to the 100th power, which equates to about 10 to the 30th power. Let me show you how fast and how often you're going to have to flip that coin. In order to achieve this problem, you'll have to flip that coin 300 million times a second for 1 quadrillion years. Anybody want to get started? Now think of this. You're flipping that penny. You got 10 heads in a row, 11 heads in a row, 12 heads in a row, and you flip up tails. You got to start all over again. That's this problem here. Just like that primordial soup would have been diluted. Get one of the wrong ones in there, you got to start over again. Now let's go back to those amino acids. The chances of getting all heads 100 times in a row is similar to the chance of getting 100 left-handed amino acids to form a biological protein. And by the way, proteins come in sizes anywhere from 50 amino acids to over 30,000. So we're just going to talk about a very small protein. We're going to be generous here today. To get a small protein of 100 left-handed amino acids, the probability would then be 10 to the 30th power, which is a number like that. You're starting to see a trillion pretty small potatoes. How believable is this, that we could get a single protein when that's the probability? 1 chance in 10 to the 30th. You see, we're being asked to believe things that are well beyond anything we know scientifically. But wait, there's more. I like those commercials. See, the number 10 to the 30th only measures the possibility of getting all left-handed amino acids. We have to get them all in the right order. Amino acid 1, then amino acid 2, then amino acid 3. If they're in the wrong order, it doesn't work. They have to be in the right order. So let's do a little more math, some fractions and some multiplication. Now, I want to let you know, this is going to be simple. This is going to be easy. Upper limits. Mathematician Emil Borel proposed 1 chance in 10 to the 50th as an upper limit that a chance event could ever occur. In other words, anything beyond that probability, he says, will never occur. Oh, but Mike, it's still possible. It's still possible. Yes, it is. Actually, it is. But if you're believing that, it's by faith, because nobody has ever observed anything beyond this probability to occur. So it's a faith issue, and we shouldn't be teaching faith in our science classrooms. So let's get 20 different amino acids. We have those. You got a bag full of amino acids there now. You got to reach in. We're only going to put the 20 that are used in life. We're going to not dilute our soup here. We're just going to use the 20. And you reach into that bag, you have to pull out amino acid number 1. You got to get it in the right order. What are your possibilities? Well, 1 chance in 20 that you'll get the right one. Well, what is the possibility you're going to get the first 2 amino acids in the right order? Well, first one is 1 in 20. The second one is 1 in 20. You multiply those 2 together and you get 1 chance in 400 just getting the first 2 in the right order. That's just the first 2. How about the first 3? What's the possibility? Well, it's 1 in 20 for the first one, 1 in 20 for the second, 1 in 20 for the third one. Multiply it all together to get the first 3 right. It's 1 chance in 8,000. It's not looking too good so far. How about the first 100? What's the possibility of getting all 100 amino acids in the right order? The first 100. Well, that turns out to be 20 to the 100th power, which is 10 to the 130th power, which is a number like that. I ask you again, what's your credulity factor? What do you think the chances of this occurring really are? Again, we're talking about a very small protein. Yes. So your credulity factor, you need to measure this. Are you willing to believe this could happen by random chance events? You know, we talked about 10 to the 130th power. I want to show you this in a practical picture. If you were just to take 10 to the 21st silver dollars, not 10 to the 130th, but just 10 to the 21st silver dollars, and stack them up, that would be enough to cover the entire United States 120 feet deep. All your houses would be covered. That's just 10 to the 21st. We're talking about 10 to the 130th to get a small protein. And cells contain thousands of proteins. Let's talk more about that cell. Anybody been in a Boeing 747? You know that Boeing 747 is made up of about 5 million non-flying parts? I want to emphasize that. Not a single part of that plane flies by itself. That gives you some confidence. So what makes that airplane fly is called design and organization, not random chance. A cell does not have 5 million parts. A cell is made up of billions of non-living parts. Not a single part of that cell is alive, so what makes it alive? It's called design organization. All those parts have to be in the right order. Sir Fred Hoyle and this other gentleman. That's how you do this. One an astronomer, one a mathematician, state that the probability of getting a single cell, now we're going to a cell, remember a protein, small protein was 10 to the 130th power, but what do they calculate is the probability of getting one cell by random chance? 10 to the 40,000th power. And then they state, an outrageously small probability that could not be faced even if the whole universe consisted of organic soup. And that is true. But wait, there's still more. Let's go to the living cell again. Our human bodies are made up of about 60 trillion cells. And what's the probability of each cell? About 10 to the 40,000th? 60 trillion cells we have in us. How long would it take to assemble 60 trillion cells at 1 per minute? Well, here's your choices. 50 years, 2,500 years, 1,500,000 years, 114 million years. D. 114 million years just to put together 60 trillion cells, but that says nothing about what shape they are or what order they are. And it also assumes no mistakes. Are you starting to see time is not an excuse? There's not enough time in the whole history of this universe to even get a single protein, let alone the cell. Now, our cells are also made up of atoms. We have to consider that. Approximately how many atoms are in an ordinary human cell? Remember now, you have 60 trillion of these cells in you. How many atoms in each cell? There's your choices. And the answer is D, about 100 trillion atoms in each cell, and you have 60 trillion of these. We're expected to believe that happened by random chance. Now, let's look at DNA. Just DNA. Software of life. John Sanford, PhD in genetics, says, there is no information system designed by man that can even begin to compare to DNA. That includes Microsoft Windows. DNA and information. Now, I have a picture of a 340 gigabyte hard drive up here. Does that mean anything to anybody? 340 gigabyte hard drive? Okay, what that means is this, that we can take something about this size, maybe 4 to 5 inches in diameter, and put 340 billion, with a B, pieces of information on it. That is incredible. That's tremendous density and compactness of information. No other generation in the history of this earth has ever been able to compact information that dense. That means we must be the smartest generation that has ever lived on this planet. We can pat ourselves on the back, can't we? We are so smart. But then I held a forum several years ago and brought some of the top information scientists into this forum. We brought in physicists, we brought in geneticists, we brought in mathematicians. And for a whole week we studied information. What is it? Where does it come from? It was a wonderful week. And then one of the gentlemen did a mathematical study on the compactness and density of information in a DNA molecule. Just one. And we wanted to compare that to this 340 gigabyte hard drive. And what we discovered was the information in that DNA was a little more compact than that hard drive. How much more compact? Over 5 billion times more compact. That's just a DNA molecule. We're not so smart after all, are we? Let me show you that in picture format. If you were to take a 2 by 2 inch slide, just cover the surface area with DNA, that would be enough information to hold 7.7 million Bibles. If you stack those Bibles up, that would go from the earth all the way past the sun. That's over 93 million miles of Bibles. That's how much information would be on that slide. Far greater than anything mankind has ever made. That means whoever put that information, that DNA, has to be smarter than anybody that's ever lived. But wait, there's still more. We're not done yet. We're going to fully test your credulity factor. Let's talk about special design and chance action. Let's go to the universe now. We talked about proteins, we talked about DNA, we talked about cells. Let's go out to the universe. Talk about the anthropic principle. Anthropos, Greek word for man. What it means is this: the assumption that the chemical and physical properties of the universe are specially suited or designed for the well-being of mankind. Notice, was this universe made just for us? Or was it a chance accident? Let's look at the atom. The proton. Now in the atoms we have protons, neutrons, and electrons, subatomic particles. A proton is 1,836 times more massive than an electron, weight-wise. But here's the problem. If the electron to proton mass was slightly larger or smaller, molecules would not form and life would not be possible. What a bunch of dumb blocks. Just happened to be just right. Isn't that amazing? How about this one? The electromagnetic coupling. The electromagnetic coupling constant binds electrons to protons in atoms. If it were slightly smaller, no electrons could be held in their orbits. We wouldn't be here. If it were slightly larger, an atom could not share an electron orbit with other atoms. In either case, molecules and life would be impossible. Aren't we glad it happened to be just right? The strong force, the strong nuclear force holds together the particles in the nucleus of an atom. If it was slightly weaker, multi-proton nuclear would not hold together. Hydrogen would be the only element we had in the universe. Wow, there's 3 things right there, just by chance accident. The Earth happens to be just the right size. If it was smaller, it wouldn't have sufficient gravity and our atmosphere would leak away into space. The Earth's gravity, the axial tilt, rotation period, magnetic field, crust thickness, oxygen-nitrogen ratio, carbon dioxide, water vapor, ozone levels are just right for life. And change any one of those, we have serious problems here. Just right. All these variables just happened. The Earth and the Sun, the distance between the Sun and the Earth is just right. We're just barely in the habitable zone. None of the other planets in our solar system are in that zone. Any closer to the sun would be too hot. Any further away, and we'd be in an eternal winter. We'd be just the opposite of global warming. The sun. Our sun is just the right color, size, and shape. If it was redder or bluer, photosynthetic response would be weaker. If the sun was larger, there would be too much high energy radiation. And if it was smaller, the range of planetary distance able to support life would be too small. Wow, look at these variables. All this has to be just right, or folks, we're not here. The earth and the moon. Without the moon, we wouldn't be here. A lot of planets have moons, but they are too small. The moon's gravity pulls on the earth's oceans, creating tides, which act as stabilizers to the climate. We got just the right size moon. Earth and moon. If the moon was closer to the earth, tides would be greatly increased and oceans would sweep across the continents. If the moon was further away, it would reduce the tides. Marine life would be endangered by the resulting stagnant water. Are you starting to see there's a lot of variables that all have to be right or we're just not here. Stars. Let's go to stars. The distance between stars affects the orbits of planets. The average distance between stars in our part of the galaxy is about 30 trillion miles. If the distance were slightly smaller, the gravitational interaction between stars would be so strong, planetary orbits would be destabilized. And then let's take a look at our galaxy. We're located right about there. Everybody see yourself. Just as our location in the solar system is optimized for life, so is our location in the galaxy. If our solar system was too close to the center of our galaxy or at the edge or any part of the spiral arms or the cluster of stars, our planet would be devastated by cosmic radiation. All those have to be just right. What we've looked at so far is the probability of protein, getting a single protein, is beyond the laws of probability. The probability of life, 10 to the 40,000th power. The information in DNA far exceeds anything mankind has ever done. The atom, the proton, electron mass has to be just right. The electromagnetic and strong forces have to be just right. The conditions on the earth, the gravity, the axial tilt. The sun is the right size, color, and distance from us. The moon is the right size and distance. And the stars and the galaxies. All those have to be just right or we don't have life on this planet. So I'll just ask you, what's your credulity factor here? Do you really believe that happened by random chance? And if you do, I'm opening up a gambling casino here. Besides, your money's worthless anyway. Didn't we just learn that? Give me your money. My personal faith is here, that there had to be a creator, designer for all this. This is far too much to believe it could happen by random chance accidents. Isaiah 45:18 tells us, "For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it, he created it not in vain, he formed it to be inhabited. I am the Lord, and there is none else." Colossians 1:16 and 17, "For by him were all things created that are in heaven, that are in earth, visible and invisible, whether there be thrones or dominions or principalities or powers, all things were created by him and for him. And he is before all things, and by him all things consist. He holds all things together." That's what God's word teaches. "I will praise thee, for I am fearfully and wonderfully made." And that's me beating Army, Air Force, and Navy. But now I want to show you something. Just having this is not enough. You have to know the tricks of the trade. How are evolutionists going to respond to you when you give them this kind of information? Well, let's look at the first trick of the trade. "Oh, Mike, it happens naturally." In other words, the formation of biological polymers from monomers is a function of the laws of chemistry and biochemistry, and these are decidedly not random. So it just happens naturally. Here's my response to that, the explanation. If it happens naturally, then why can't scientists duplicate this in the lab? Are we saying random chance is a lot smarter than all our scientists? And secondly, amino acids do not spontaneously form together to make biological protein. That is a total misstatement they make in biology and chemistry. It does not. It requires energy, but you also have to have an energy source that's going to capture that energy. You got all left-handed amino acids. The natural tendency is to bond left and right-handed. You got to get them all in the correct order. It requires instructions from DNA to do this, but we don't have DNA yet. We have only not even proteins yet. And then you have the problem of oxygen can't happen. No oxygen can't happen. Water, it can't happen. Don't let people say it happens naturally. That is misunderstanding of biology and chemistry right there. But yet that's what they're using on our children. They're deceiving our youth into a belief that there is no creator God, which means there's no Jesus Christ, because he's the creator. The deck of 52 cards. In a deck of 52 playing cards, there are almost 10 to the 68th possible orderings of the cards. So you got a brand new deck, and you shuffle that deck. Then you show somebody, maybe you got this, maybe you have this order. You show them, well, here's the order I got. I got this deck of cards, and I opened them up, and this is what they look like. What's the possibility of getting this order? There's 1 to the 68 possibilities, but I got this order. What's that possibility? Be careful. There's a logical fallacy in what they're trying to do here. Number one, in this example, the math is correct, but their interpretation is completely wrong. You see, if the arrangement had been specified before they shuffled, that would be an astounding thing. But see, they're telling you the order after they shuffled. See, it's an after the fact. You see, I could shuffle a deck of cards and then show you the order, say, wow, look at the order I got. But if I had said, before I shuffle the cards, I'd say, I'm going to get this order, and then shuffle the cards and get that order. That's amazing. But doing it after the fact, the probability is 1. It's going to happen. You're going to get some order. So there's a logical fallacy in what they're doing there. Here's another one. All the people. This is the one they used against me when I was at NASA. We're all in a room of 100 people. What is the probability that all 100 people would be here in this room at the exact same time? The probability is enormous, but yet we're all here. Explanation. There are 2 things wrong with this reasoning. Number 1, the people were not pre-specified. This is another example of doing your prediction after it occurred. I'd like to see them predict before the people get there. And secondly, each person made an intelligent decision to come. See, this was not random chance. This was an intelligent decision. So once again, misunderstanding of probabilities. Probability is not involved. Probability has nothing to do with evolution. Evolution has no goal or objective. Why don't they put that in the books? Some problems with this. That disagrees with our modern biology textbooks and mathematics. See, when there's more than one possible outcome and the outcome is not predetermined, probability becomes a factor. And we saw probability all over just getting a single protein. And we saw the probability was far too great that that could occur. So those are some of the tricks of the trade they're going to do. Now I'd like to talk more about the incredible human body. You know, we contain more than 40 billion capillaries. And if you were to stretch yourself out, that's 25,000 miles in you. No such thing as a short person now. Imagine that, 40 billion capillaries. A heart that pumps 100,000 times a day. Red blood cells that transport oxygen to tissues. White blood cells that rush to identify enemy agents in the body and mark them for design. Those are the true heroes in the body, those white blood cells. They sacrifice themselves to keep you healthy. Isn't that amazing? Ears and eyes, which are more complex than any man-made machine. A brain which contains over 100 trillion interconnections, can do about a quadrillion calculations a second, and contain about a quadrillion pieces of information. Wouldn't you like to be able to recall all that? And many other parts, such as the nervous system, skeletal, liver, lungs, skin, stomach, and kidneys. All those have to be arranged just right. Remember the possibility of getting a single protein? Was 10 to 130th power to get a single protein for life. The possibility of getting a single cell was 10 to the 40,000th. When you look at all of this, I would conclude this. Every human body is a testimony to a purposeful, all-powerful Creator. Let's finish with some scripture. The hearing ear and the seeing eye, the Lord has made them both. 1 Corinthians 12:18. But now hath God set the members of every one of them in the body as he hath pleased him. I'll finish with this last one. Malcolm Muggeridge, teacher, author, and journalist, writes this. And it kind of puts everything in perspective. One of the peculiar sins of the 20th century, which we've developed to a very high level, is the sin of credulity. It has been said that when human beings stop believing in God, they believe in nothing. The truth is, much worse, they believe in anything. That is the truth. Just take a look at what's happening in our school systems today. Look at our youth coming out of these school systems, believing in anything. Thank you, and God bless you.
This has been Evolution and Mathematical Probability, presented by Mike Riddle. To receive a free catalog of over 200 awesome Stealing the Mind Bible studies on DVD, CD, or audio tape, information on upcoming Bible conferences in your area, or details of our missionary outreach and trips to Israel, call Compass at 1-800-977-2177 24 hours a day, or on the web at compass.org.